Hi, to finish up this module, let's talk about luminosity and bolometric corrections. So we defined the bolometric flux as the flux integrated in all wavelengths, where the flux is the energy over area over time. Now, luminosity is the quantity d dt, energy over time. In physics, it's called power, but in astronomy, we call it luminosity. So as you can see, the luminosity is the flux times the area. So for a source of constant luminosity, as most sources in astrophysics are, you can see that the flux is going to fall as a constant over the area, recovering the inverse square law. For a spherical star, the area is 4 pi r squared, and then we can write that the luminosity of the star is going to be 4 pi r squared times the flux of the star, where f star is the flux of the stellar surface. Now, as you can see, there seems to be a close relationship between luminosity and absolute magnitude. They're both measuring an intrinsic brightness of the star, but they are not identical. Luminosity and absolute magnitude are not yet identical. The reason is because the luminosity corresponds to the bolometric flux of the star, whereas magnitudes are usually measured within a specific range of wavelengths, a waveband. Right? Parkus and Ptolemy, they worked with the naked eye, so they did not have means to measure any other region of the electromagnetic spectrum. They couldn't measure infrared, they couldn't measure ultraviolet, they could only measure what their eyes could see, which are the visible wavelengths. So we call these visible magnitudes. We can call the apparent visible magnitude by the letter V, and then the absolute visible magnitude by MV. So if you want to convert these magnitudes to luminosity, you can apply a bolometric correction, and then you're going to have a bolometric magnitude that is a measurement of the luminosity. The bolometric magnitude is the visible absolute magnitude plus this bolometric correction. Let's call it BC. So for the sun, the absolute visible magnitude is 4.83, and the bolometric correction is minus 0.09. So the sun has only marginal bolometric correction because most of its energy is radiated in the visible. As you can imagine, if a star is much colder, it's going to have most of its energy in infrared. The bolometric correction is going to be significant because the visible absolute magnitude is going to be small, and you need to add a lot of energy to get to the true bolometric magnitude. The same thing for a hot star that has most of its output in ultraviolet or bluer wavelengths. So you can define the bolometric magnitude in terms of the bolometric flux. And remembering that the flux is the luminosity over the area, this simply becomes the bolometric magnitude is equal to minus 2.5 log of the luminosity over 4 pi d squared.